express as a single logarithm, the first question you have here is 3 log to base 6 of x plus 5 log to base 6 of x negative 6. Now the second question you have is use the change of base formula and a calculator to evaluate the logarithm. Round your answers to 3 decimal places. So you have been told to round your answers to 3 decimal places. And then this is what you're told to use the change of base formula for. So I'm going to start by answering the first question. So when we are done with that, we'll move to the next question. Now for the first question that we have there, which is 3, what we're given is, we're given 3 the log to the base 6 of x plus 5 the log to the base 6 of x negative 6. Now if you're told to express this algebraic expression as a single logarithm, now before I do anything, I want to show you one of the laws of logarithm that says that if you have log, the log of log to the base a of m and then raised to the power p. Now whenever you have anything like this, it's as if what you have here is like an excess. So to balance this up, the excess becomes the coefficient of the algebraic expression. So in other words, this becomes, so you have p log to the base a of m. So what's happening here is I'm going to do the reverse operation here. So you'd observe that the coefficient here was here initially. So what you have here is you have a coefficient, so which is 3. So what I'm going to do now is I'm going to do the reverse operation. I'm going to bring the 3 here, I'm going to bring it here, it becomes a power, and then the 5 that you have here is also going to become the power of x negative 6. Applying this, so in other words, 3 log to the base 6x becomes log to the base 6 of x. Now the 3 becomes an excess here, then plus, so you have 5 log to the base 6 of x negative 6, so it becomes log to the base 6 of x negative 6. Then the 5 you have here becomes the power, so you have 5 here. Now this is the first step I carried. The next step I'm going to carry is I'm still going to lay credence to one of the laws of logarithm that says that if you have log to the base a and say you have m plus log to the base a and then you have n. So what the law says is that anytime you have an addition sign here, it is translated to a product sign. In other words, what you have here is going to be log to the base a of m. Now the plus here becomes multiplication, m times n. So what you have here is two logarithms, the logarithm of two numbers in which you have the plus sign between them. So I'm going to apply this law here. So this now becomes, you have log to the base 6 of, so my first term here is x cubed, so you have x to the power 3, then the plus here becomes a product sign, and then you have x negative 6, while the power here is 5. So this is your final answer. So your answer is just this times this, or you can as well write it as log to the base 6 of x to the power 3 times x negative 1 to the power 5. So this is the final answer. Now the next question says that use the change of base formula. So we are in the next question now. You want to use the change of base formula and a calculator to evaluate the logarithm, this logarithm here, and then we are told to round our answers to 3 decimal places. So let's write down the number below. So the number we are given, which is 4, is the log to the base 3 of 72.04. So we want to find this logarithm here, applying the change of base of logarithm. Now before I do anything, I want to show you something. Assuming you're told to find or to apply the change of base of logarithm formula on log to the base, let's say you have x and let's say you have another number, say y. Now what the change of base of logarithm actually says is that anytime you have two numbers in this format, you can introduce a new base. Looking at this number here, the base we have here is x. But then if you want to introduce a new base, what you have up becomes the numerator, and then what you have at the bottom becomes the denominator. In other words, if I wanted to introduce a new base, say a new base a, so this number becomes, to make it equivalent, so this becomes the log. So this is my new base a, and then what I have on top there is y. So let's say this is y here. Now divided by the log to the base a. So let's say you have a here, and then our x that we have here, so this becomes x. So all I just did was I introduced a new base. So introducing a new base displaces what you have on top, and then the one at the bottom becomes the denominator. So in other words, if I wanted to introduce, say, maybe a new base e, so this is just going to be the same thing as the log to the base e. So what you're going to have is e, and then what you have as the power is just going to be y, then divided by the log to the base. So instead of a, now we are having a new base which is e, and then you have x. So I'm going to apply this to this new number here. So what I have here is log 372.04. so this becomes, so you have log of 72.04 divided by log of 3. So the new base that I'm going to introduce here is e. So we're going to introduce the base. We're going to write e here, and we're going to write e here. So you note that this is the same thing as the natural logarithm. In other words, this is log to the base 72.04 to the base e. Now this is the same thing as the ln of 72.04 divided by the ln of 3. Sorry, the ln of 3. So all we need now is to use our calculator to find these values here. So let's bring our calculator out. So now when we check our calculator, we point it on, then we go to the ln of 72.04. So we check for the ln sign. This is the ln sign here, which is the second function of x. So you point in second function x. So you see the ln sign here, it opens brackets, so it goes 72.04, and then you punch in enter. So the answer we have here is 4.2772. So we write 4.2772, now divided by the ln of 3. So what's the ln of 3? So we go again, second function of x, the ln of 3. So this is just going to give us 1.09861. So this is just going to be 1.09861. And then what's this going to give us? So let's just check again. So we have 4.2772 divided by 1.09861. So this is just, that gives us 3.89328. So since we're told to approximate the answer to the nearest 3 decimal places, so this is 3.89328. So let's say we have 3.89328, and then you have some other numbers on, but since we wanted just 3 decimal places, so it should just stop, it should stop here. So that means approximately our answer is going to be 3.893. It says 3 decimal places, just 3 decimal places. So this is going to be our final answer. So that completes the problem.